All right, welcome back. Second lecture of our 3D series. And what we're going to do today, now that we've seen how we can deal with geometries in 2D using translation, rotation, moving the camera, things like that, we are going to see how we can take something we've already made in 2D, something that's kind of complex like our particle system, and convert it to a 3D scene. Now, I really love this lecture because I think what we end up with at the end is just very interesting looking, and I think it'll hopefully foster a lot of ideas of what you might do for your assignment with making your own 3D scene. Could be using these elements, could be something totally different. So what we're doing today is taking our 2D particle system and converting it to a 3D particle system. So let's think about what we had before. Okay, so we had, let's see, we had our screen here, right? Oh, terrible noise, okay. All right, so what are, this is, by the way, this is back in week 5. We made our 2D particle system. And where we ended with, we had like that mouse emitter, and every time we scrolled our mouse and clicked it, particles kind of shot off. We had both a particle system that kind of bounced off the walls, and we had the walker class that did the random walk. So basically it looked something like this. We had a whole bunch of particles, and they were zooming across the screen. They'd hit a boundary, bounce off again. We also had that lifespan attribute where they would fade out over time, so that we'd kind of draw something and then go away. So what we're going to basically do is convert this from having points on a flat, 2D rectangle bouncing off the walls to, we're going to change it to be thinking about it like a container. Make this a little bit smaller. So we're basically going to have a very large box. We're going to use that 3D primitive that we saw last lecture. We're going to have a box that's basically going to be a container for our 3D particles. So instead of bouncing around on a 2D rectangle, they're going to be zooming around in a 3D box, and we're going to have it so that when they go outside of the box, they'll just regenerate inside of it. So kind of like a snow globe sort of idea. So we'll have our particles in here, they'll be zooming around, and then once one goes outside of the box, they'll just reset back somewhere inside of it. So to do this, we're actually going to use our sketch from week 5 and just use that as a starting place so we don't have to redo all that code, because we're going to use a lot of the same ideas. We're just going to be adding that third dimension to it. We're also going to add some navigation with our keyboard, just as another possibility for how you might want to be zooming around in your 3D scene. But that's the two main things that we're going to be making our 2D particle system to 3D, and then we're going to add keyboard navigation as well. Okay, so let's jump into that. All right, so excuse me. I've already done this, but I pulled up the week 5 sketch that has our particle systems here, that had the particle and the walker. And what I did was I went to File and Save As, and I saved it. Here we go. I saved it as Week 7 Class 1B. I'm not going to do it again, but you would want to hit Save. So now we have the same sketches we had in Week 5, but now it's called Week 7 Class 1B. All right. Now, the first thing before we get into any of the 3D stuff is I want to kind of simplify this a little bit. I want to get rid of the walker class altogether. I want to get rid of the mouse part of it. But let's just quickly take a look at what this thing was doing, just so we can kind of remember where we left off with our particle system. Okay, so there we go. We had our particles. The black ones were our particle class that kind of bounced around. The white ones were our walker class that did the random walk. And as you can see, yet again, my computer is struggling a little bit with the screen recording and processing. I will give it a pass since it's like a 11-year-old computer at this point. But what we want to do is get rid of some of that just to simplify this whole thing a little bit, because we're thinking about things in 3D. We don't need to worry about all the kind of cool things that we added before. So first things first, I'm just going to go ahead and get rid of the walker class altogether. So I'm going to click on that tab, and then you click on the arrow and say delete. It's going to ask us if we want to delete walker. Yes, we do. Goodbye. All right. So you'll see that now we have some warnings because it doesn't know what walker is. Well, that's good. We don't want it to. So I'm going to get rid of this list. If you remember, these were our lists where we stored all of the particles or the walkers that we had. So we just want to just have a list for particle. Okay. Now we want to get rid of this one. This was our loop where we said for all of the walkers that we have, run the display function. Well, we're not having any walkers, so let's get rid of that. And now finally, I don't want to deal with the mouse thing in this one anymore. So when we had this idea of a particle emitter where we clicked and it added new particles and new walkers, adios. Okay. Now what I do want to do is bring back this. So this was our loop that created a certain number of particles right when we launch our program. So we defined this number total, 100 particles, and so we said a loop here that said, okay, make 100 new particles with a random location, or no, sorry, at the middle, I should say. And then I think we said the size of it, and then the x speed and the y speed. Let's confirm that that's true. X position, y position, size, speed x, speed y. Perfect. Yep. So that's what that's doing. And let's just clean up some things since we've seen how to create particles. We don't need all of the little reminders, so we can get rid of that as well, just to simplify things a little bit. We'll get rid of this because we're not using it either. Okay. So this is a lot more clean and clear. I like that. All right, so now if we run this, we should just be getting 100 particles at the beginning that zoom around our screen. And there they go, bouncing around and fading out, just like we wanted. Perfect. Okie dokie. So we need to add sort of 3 different components to our sketch today. We need to first convert our particle to be 3D and not just 2D. We need to add what I'm going to call our scene tab, which is what we're going to use to draw our scene. So we want that box that we're going to contain our particles in. We're going to want the global translation and rotation. Remember from the last lecture, we would translate to the middle and then have a certain amount of rotation. That's all going to be part of our scene. That's like how we're going to actually draw our 3D environment. And then we're going to have one other tab called nav for navigate, and that's going to be using our keyboard to navigate through our 3D scene. Okay, but first things first, we need to convert this particle class to 3D. Now, thankfully for us, really all that means is we need to just add some z's for now. We're going to change some stuff down here a little bit in a bit, but for now, really what we need to be doing is saying, now we have a z, we have our 3rd dimension z here, and that means we're also going to need z here, float z underscore. All we're doing is making sure we now have a z component to go with our x and y. Okay, and then we could also have z speed, why not, right? Speed z. And we'll add that here as well. So now we have 3 independent speed variables, one for x, one for y, one for z. Speed z equals speed z underscore. Great. And we'll come down to our display where we're actually drawing our particle. and we'll just make sure that we are using our Z speed as well and updating that. Great. So all that's changed is now we have Z components. I'm going to go ahead and get rid of this lifespan stuff, just because we're not going to be using like our particle emitter to generate more particles. We're just going to have them respawn somewhere inside the box once they go outside of the box. So we want them to always be visible. So I'm going to get rid of lifespan there, and maybe we'll just get rid of it here too, just to clear things up. Okay, so stroke weight was our size, our stroke was black, our point now needs to be at X, Y, Z. X, Y, Z. Okay, great. So we now have that going. Cool. So we're going to come back to this boundary idea because we're going to need to change this a little bit to be referencing the box that's our container for the particles. But let's just leave it there for now and address some of the other parts of our sketch. So first things first, we need to tell processing that we're doing a 3D sketch, right? So first thing we need to do is tell processing P3D. We're now rendering a 3D scene, not a 2D scene. And you notice that we now have an issue with how we're creating our particle. Well, that's because we've added new features to the particle class, Z and Z, speed and location. So we need to have that reflected in the way we're constructing a new one. So we need to say, what do we want our Z to be, and what do we want the speed to be? So let's start with the speed. So over here, we're going to say random. Let's stick with the same idea of -2 to 2. So now we have X speed, Y speed, Z speed. Now one thing I kind of like to do, once you start to get this many arguments for a class, it gets a little messy, right? So what I kind of like to do sometimes is to just break this up a little bit just to make it more clear. And I put each of these on a new line. So I'm just going to the beginning of each argument, hitting enter to place them on a new line. Okay. And so the reason why we're still getting this is because we still need one more argument. So let's just put something in here for now, 10, just to get rid of our errors here. Now we'll come back again to this, which is where do we want the origin of each of our particles to start. We're going to come back to that because we're going to want to again be referencing our position based on this box that we're going to draw to be our container. So let's go ahead and start drawing our scene tab, and then we're going to come back and adjust both the starting location and the boundary locations to be based on staying inside of our box, our container for our particles. Okay, but other than that, this is looking basically ready to go. Okay, so what I'm going to do is I'm going to create a new tab, and I'm going to call it scene. Okay, and what we're going to do is we're basically going to make this into a function. So I'm going to say void scene. So this is a function we've seen before, right? How we can make different functions and then we just call them over here in our draw loop. We're just going to do the exact same thing. We're going to make a function that basically draws our entire scene for us, and we'll use that function in the draw loop to have it run every single frame. Okie dokie. So what we need to do, first things first, we're going to come back to our global translation and rotation. Remember from the last lecture we had some kind of translation or rotation to affect the entire scene. We're going to come back to that in a minute because that's going to be based on our keyboard. But what we want to do is we want to draw our container for, let's do a comment first. We'll use our box container for the particles. Okay. All right, so let's make that box. We'll call it stroke 0. We'll do no fill because we want to see inside of our box, which is where all of our particles will be. Now we just need a box. Okay. Now what size do we want here? Well, we could just put in a number, right? Like 200 or something. But the way that I like to think about this is to actually use a variable. Because that way we can both change this later if we want, but also we can reference the variable that we use to set up the size of our box to help deal with the boundaries later. That will become more evident when we come back to our particle, but just hang with me for the moment. So I'm going to create a variable that's going to be called boundary. Okay. And I'm going to come back in a bit to explain why we're going to multiply it by 2, but just know that that's going to be useful for us later. Okay, so I haven't actually created this boundary variable yet, so let's go ahead and do that over here. So let's say we have int boundary, and let's make it maybe like 200. How about that? Cool. All right, so our boundary for our box is going to be 200, and we want to make our box that's boundary times 2. And the reason why I'm doing that is because we're going to be thinking about our box in terms of positive and negative boundary. So we're going to have, let me draw this actually, this will be helpful. Okay, so here's where we had our box, right? So let me clean this up just a little bit. Okay, so here's the origin of our 3D scene. And we want to think about boundary kind of like the radius. So we're going to have positive boundary going this way and negative boundary going this way. So we know that boundary was 200 this way and 200 that way. So that's why we're doing the whole boundary times 2 idea. So because we have a center point and we're having our box go boundary this way and boundary that way, the entire size of the box then is boundary times 2. And this happens in all 3 dimensions. So we go up and down, and we go in the z-axis forward and back. So each of those will have 200 pixels in, 200 pixels back, along the x direction and on the y direction. So we're setting basically, think about like the radius. We're setting the radius, but then the entire size of the box is actually, radius times 2. So that's why we're saying create a box that's boundary times 2. But we're using that because later we're going to say, for example, if our particle x location is greater than boundary, that means it's gone off the screen over here on the right. And if it's less than negative boundary, that means it's gone off the screen over on the left side. So that's why we're kind of doing this like funny little boundary times 2 business, but it all works out. Okay, let's get back to it. All right, so we now have our box. That's going to be our container for our particles. And we set some, just some parameters about the box. That's great. We have our kind of 3D settings all good to go. We have our boundary set. We're adding particles. Okay, so let's do 2 things now. The final 2 things we need to do to set up our particle so that it's kind of referencing this new boundary that we created, this box. So instead of doing, like width divided by 2, height divided by 2, we're going to change the initial location of each particle to be referencing the boundary. So what does that mean? Well, here's what it means. I want to basically place each particle at some random position between negative boundary and boundary. So we're basically saying somewhere along the x-axis, that is within the boundaries of our box. Negative boundaries, so negative 200x to positive 200x. Now I'm just going to copy this because our box is a perfect cube, right? It's the same size in all directions. I can just say that we want this to be the case for x, y, and z. And now the reason why I kind of broke this up into separate lines is now we can do something like this. So initial x location, y, z. So here's our initial locations. We're putting it somewhere between our boundaries of the box. This is our size. This is our x speed, y speed, and let's get rid of that comment, and our z speed. Okay. Now we're getting some, I might be missing a parenthesis here. Ah, there we go. Okay, great. So, oh yeah, because I added these extra parentheses for the randoms. Okay, great. So now this is just, because we had so many arguments now to deal with our particle, I feel like this is a little bit easier to read it now when we're constructing it. Okay. So now we are creating a new particle somewhere randomly inside of our box, and we still have size and speed. Now let's do one more thing before we see where we're at when we run this. I want to change it so that instead of having the check for boundaries, just referencing the width and 0, height and 0, that's kind of more of our 2D approach. We need to think about this in our 3D approach, which we can use our boundary variable to help us with. So I'm going to just start this part from scratch just so we can get a clear idea of what's happening. So let's just get rid of this. Give a little space here. So we're going to say check for boundaries. We're not going to worry about reversing direction. We're going to say check for boundaries, and we'll say respawn in a random location inside the box. All right. So we're going to write an epically long if statement here to check for our boundaries. So what we want to know is, let's start with x. So we want to know when x has gone outside of the boundaries. So what we can do for that is we can say if x is greater than boundary on the one side. It's kind of like saying if x is greater than width, but now in our 3D context. Or if x is less than negative boundary. So this is kind of like when we would say height in 0, width in 0. Now we're saying, all right, have we gone beyond our boundary on the positive side? And have we gone beyond our boundary on the negative side? And we basically just do this for all 3 of the dimensions. So we'll do it for y. I'm just going to copy and paste this because it's all the same. Y and z. We'll get a curly bracket here for our if statement. Okay, so what this is saying is if any of these are true, if x is outside on the boundary, even if none of these are true, all of these or operators are saying basically if any one of these conditions is true. Could be any of them. It's basically saying, hey, are we outside of the bounds on any direction? If that's true, we just want to reset our x, y, and z to some random location, just like we did when we created the particle in the first place. So all we have to do for that is say x equals a random number between negative boundary and boundary. We'll do the same for y. Now you can kind of see why I use this boundary variable. It makes our lives a lot easier if we were to ever wanting to change the size of our box, because we don't have to change that number, imagine if we had written like 200 here, we'd have to change every single one of these, but because we just have a boundary variable, they'll all be referencing the same number. Okay, great. Let's just see where we're at when we run this thing. Loading very slowly now, but we'll get there. Okay, so we're seeing something here. So part of this issue, if you remember from our last lecture, is that because we didn't have any global translation or rotation, everything is still based on this 0, 0 up here on the top left corner. So that's something we want to change. We're also not seeing our box, so that's something we need to adjust in our scene. And then the final thing is we need to add our navigation to this as well. But the nice thing is it's kind of hard to tell. It looks 2D, but we know for a fact that this, because we put it in our class, that we are getting a 3D particle system. We're just not able to see it super well right now. So let's deal with that. Okay, so why don't we jump into the navigation part of our code so that we can start exploring this 3D space with our keyboard. So in order to do that, I want to create a set of variables here. So just like in the last lecture, we used variables for both the rotation of X and Y with something like that. We're going to do the same thing, but for all three X, Y, Z, and for the position of our camera. So let's see first what the variables will be. So I'm going to create a whole bunch of floats here. I'm going to say rotation X, rotation Y, rotation Z. And I want variables for the position, so the translation of our camera X, camera Y, camera Z. So we'll say this is the rotation and translation of our camera. Cool. Let's say of our navigation. That's probably a navigation, because we could still use the PZCam, which we saw before, if we wanted to, where we don't really rotate anything in the scene, but we move our camera around. In today's version, we're going to actually be rotating all the geometries, and that will be our navigation. So here's our variables for that. Here's our variables for all of the rotation and all of the translation. Okay, so now let's make a new tab. We're going to call it nav for navigate. I realized why we weren't seeing the scene, right? We didn't see our box. That's because we created this function, but we actually never called it in our draw loop. So if we were to put scene, we would see our box. Let's just confirm that. Ever so slowly. There we go. Okay, great. So now we can kind of get this sense of a 3D space that our particles are bouncing around inside of. Great. So we'll now with our navigation, we'll be able to make this kind of set up in a nicer way. Okay, so I'll put a comment here. Run the scene function to to draw our scene. How about our 3D scene? Great. Okay, now let's hop over here to nav. So what we're going to do, just like with scene, is we're going to create a function for nav. So later we'll be able to run this function, and it's going to keep track of all the navigation we're doing in our 3D scene. So we want to do this well, I don't know if you do, but I do want to do this with our keyboard this time instead of the mouse. So what I'm going to do is I'm going to set up a key pressed scenario. So I'm going to say if key pressed, get some space in here. Oops. Okay. And what basically we're going to have happen, just to give you a preview, is what we want to do is have the up and down arrows be affecting our rotation of X. We want to have the left and the right keys, arrow keys, be changing the Y rotation. And we want to have two other keys, I'm going to use W and S, to be zooming our, kind of going forward and backward through our scene. Now you can make this even more complicated if you want, but that's kind of a good starting point for navigation. So we know that if we want to use those arrow keys, we've seen this before, right? This coded thing. Let's get that into place. Just making this a little bit cleaner. Okay. So now let's start with our X. So if the key code is up, what do we want to do? We want to increase our X rotation. So later we're going to use, rotate by that amount. But right now we're just setting up that variable based on input from our keyboard. So increase X-axis rotation. All right. We'll do the same now for down. And now rotation X, we're going to decrease it. Decrease X-axis rotation. Very cool. Now, so we have up and down. That's going to be like kind of nodding. Think about that. And then left and right will kind of be like shaking our head. So we'll do if key code equals left. We want our rotation Y to increase. Increase Y-axis rotation. Rotation. Oops, I have a typo here. There we go. And finally, if key code equals right, we want to decrease that rotation. So shaking left, shaking right. That's kind of how I like to think about it. You can think about it like maybe like a camera tripod too, where you have panning and tilting and things like that. So we're going to say decrease Y-axis rotation. Very cool. Now we just need one more item in here. So we need to be able to move forward and backwards in our scene. So to do that, I said I'm going to use the key W and S. You could use any key you like, but that just kind of makes sense to me. So if I do W, I want to camera Z plus, so I could say plus plus, but that ends up being pretty slow. We've seen that we can move things faster by doing something like this. All right, so we're going to increase camera Z position by 10. And let's be clear, I guess, we'll increase navigation Z position by 10. Probably it would make sense to make these called nav Z and whatnot, because camera probably should be reserved for when we're actually moving the camera. In this case, we're actually moving the geometries, but yeah, that's okay for now. And then finally, we said key equals S. We want to decrease navigation Z position by 10. Okay. So quick recap here. Let's get rid of that space. We basically have now created a keyboard interaction in which our up and down arrows are kind of like nodding our head up and down, and our left and right arrows are looking left and right, and then W and S are moving us forward and backwards in our space. Okay, so now how do we actually use these variables that we've created in our scene to actually change this? Well, we're going to go over here to our scene, and we're going to use those variables that we've been changing with our keyboard. So I remember I mentioned that we're going to have some global translation and rotation. Well, that's what we just did with our navigation. We set up each of these variables. So what we want to do is we want to translate based on camera X, camera Y, and camera Z. Now, we didn't really do anything with camera X and Y. You could make it more complicated, but I wanted to show kind of the most minimal version of how we can navigate the 3D scene with our keyboard. Okay, and now we need some global rotation. So we'll say rotate X. Well, we want to do what we saw in the last lecture, radians, rotate X, semicolon, not colon. Now I'm just going to copy and paste this for each of the other dimensions. So we got Y, Z, Y, Z. Okay, great. So now the last thing we need to do is make sure we're actually calling this nav function. So I'm going to say scene nav. And let's see what we got. It probably will take a second to run here. Okay, now we can see that we are getting some movement here with our keyboard. Great, we're getting some rotation. Now we're still kind of getting this unfortunate origin up in the top left corner. So there's a couple ways to solve that, but one thing I like to do with this example is to augment the navigation we're doing with the PZCam. Because remember in the last lecture we saw that PZCam automatically kind of centers our geometries for us. So we're going to kind of leverage that, that feature of PZCam. So I'm going to say import our PZCam just like we did the last time. And we'll do the same initialization as before, PZCam. That's an instance of our class PZCam that we'll call cam again. So initialize camera. There we go. And now in our setup, we want to actually set up those initial values. So we'll say cam equals new PZCam. And then we'll do the same distance as before, the 600. Okay, great. Now let's just see kind of the effect that we get. Running very slowly today. There we go. Aha. All right, so now we are into the middle of our screen, which is what we want. And we're able to rotate around. Now, you can't see me hitting W and S, but for some reason that's not working. And that's because we have the conditional statement for those two keys. I realize it's actually living inside of our key code conditional, so we need to make that small adjustment. So we're going to come back into our navigation. And you can see that our if key equals W, if key equals S is still inside of our if key is coded. Well, that's no good, so we're going to take this, I'm going to bring it outside of there, and put it down here. I'm going to hit a Command T just to clean things up a bit. And now let's run this again and make sure we're able to move forward and backwards. All right, there we go. Now we can zoom forwards, we can zoom backwards, we can kind of aim with our other keys. And so now we have a really basic way to navigate through our scene. And you, like I said, you can make this more fancy. You could add extra keys to change other aspects of it. You could also still, because now we have PZCam, you could still have it based on the mouse. And this is kind of a good illustration of the fact that it looks basically the same when we're doing this. Right now I'm manipulating it with the mouse. Now I'm doing it with the keyboard. But we're actually doing two very different operations. The keyboard is actually rotating all of the geometries inside of here, whereas PZCam is just rotating the camera, the perspective of all this, of all of our scene. Okay. So it's going to be in your assignment to create your own 3D scene to basically use these concepts of the camera, of rotation, and then having something interesting moving around inside of it. What I like about this example is it's kind of, you know, our complicated particle system, but in a more interesting space, and especially now that we can, you know, navigate it and actually go inside of here and look around. Yeah, I'd probably, if this were me, I'd want to make the window size a bit bigger, just so that it's it feels a bit more immersive. But yeah, I'm going to leave it up to you to decide what goes in your 3D scene. But I would just have make sure you have your navigation set up so that you can explore that scene. Okay, so in our final lecture for 3D processing, we're going to look at how to get some more complicated elements into our scene. So we're going to be looking at lighting. We're going to be looking at how we can take an image and basically wrap it like a texture around an object. So for example, we could take an image of a planet and wrap it around a sphere so that it looks like that planet, for example. And then we're going to also look at how to import a .obj file, which is a 3D file, so that you could either design your own 3D geometry or, you know, pull one from the internet and import it into your 3D scene. All right, so that's all we have for today, and we'll see you next time.